All right, welcome to 12.3, Tangents, Lines, and Velocities. So calculus is a branch of math that studies the rate of change of functions, okay? So you're basically going to take everything that you know from Algebra 2, Algebra 1, Geometry, and Pre-Cal, and put it all together when you get to calculus. So here, if you remember from geometry, a tangent line, is a line that basically hits at one point on the outside. So what calculus does is basically check to see what the slope of that line is. That's the first derivative. And then you'll get into other things like second derivative and so on. But first derivative basically finds an equation for a tangent line, and then you can find the slope of that line. So you can find the slope at any point, and which later on we'll talk about. It also is, you're able to find velocity at a certain point. So the slope of a line indicates the rate at which a line rises or falls. For a line, this rate is the same at every point on your on that line. However, for other graphs, like this polynomial function, the rate at which it rises or falls changes from point to point. So if I put a tangent line here, that's a positive slope. But if I were to put a tangent line over here, that's going to have a negative slope. And depending on where I put it, some places it's going to be steeper than others. To determine the rate at which the graph rises or falls at a single point, so for example, a point right here, you can find the slope, that's supposed to be slope, not slop. Slope of the tangent line at the point P of xy. Okay, so the definition, the slope of a line, the slope m of a graph of f of x at point x, okay, is equal to the slope of the tangent line, and is given by this function. So it's the limit as h approaches 0 of f of x plus h minus f of x over h. So anytime that I'm trying to find the limit as x approaches something, I'm going to basically what we call find a derivative. And we'll talk more about that later. That's just more words to describe what you're doing. So I want to find this for this function. So all that means is when I have x plus h, instead of having an x here, I'm going to put an x plus h in its place. Then I'm going to subtract off the function itself. And then after all is said and done, and I clean it up, I'm going to substitute h in, or 0 in for wherever h is. Until then, until I actually substitute 0 for h, you can't do it right now, but when I substitute 0 in for h, you need to write this every single time. If you don't write the limit as h approaches 0, you're not doing the same kind of problem. And when you take the AP test, they will mark it wrong if you do not put all those limits on there. Because having a limit of something is different than the function itself. Okay, we kind of talked about that. The limit of something is not necessarily going to be the same as a value itself. So the first thing I'm going to do is I'm going to find this, my f of x plus h. Let me change my pen width. So my f of x plus h, basically you're just substituting x plus h in where the x was. So that's 7x plus 7h plus 5. Okay, so that part I know I need. So now, let me squeeze this down. Oops. Let me squeeze this down smaller. I'm going to move this over here. Okay. Now, I can find my limit as h approaches 0 of my f of x plus h is all of this. 7x plus 7h plus 5. That's f of x plus h. Minus my f of x, which means you're just subtracting off the function itself. You have to be careful when you're doing all of this to keep everything straight. So my limit as h approaches 0, and you need to write this limit every single time until you actually physically substitute in 0 once we get it simplified. Because I can't substitute 0 now because I'll get undefined. I have to clean this up before I can do that. That's going to give me 7x plus 7h plus 5. Distribute the minus sign, that's the most important part, over h. And you'll notice that this and this will cancel. This and this will cancel. And I'm left with my limit as h approaches 0 of 7h over h. And in this case, your h's will cancel, which means you have limit as h approaches 0 of 7. And since there is no h left in here for you to substitute in, your answer is just going to be 7. That is my limit. So, and kind of think of it, we just talked in the last screen. What kind of line is this? This is 7x plus 5. So I kind of already knew, remember finding this limit process here finds the slope of a line. Well, we already know that no matter where you go on a linear function, your slope is going to be whatever is in front of x. And so if you did all of your math right, you should get that your limit is 7. Now that won't be the same necessarily for other functions. You're actually going to get a function. And so we'll do those on the next screen. Okay, so this one, I'm going to do my limit as h approaches 0 of 2 times x plus h squared plus 3 times x plus h minus 5. That's this part. Minus the function itself. And that's all over h. So when I do that, I get my limit as h approaches 0. Okay, so remember, you're going to have to multiply this out. So this is going to give me 2 times x squared plus 2xh plus h squared. You need a FOIL. That's where your binomial theorem sometime will come in handy if it gets bigger. Plus 3x plus 3h minus 5 minus 2x squared minus 3x. Oops, I ran out of space. Hold on, let me make this a little smaller. Plus 5 over h. So then I have a limit as h approaches. So on the last screen, we got to the point where we were at the limit as h approaches 0 of 1 over square root of x plus h plus 10 plus square root of x plus 10. So now once we get to this point and we've rationalized the numerator, you can plug in 0 for the h. So now you don't have to write the limit anymore once you substitute. So this is 1 over square root of x plus 0 plus 10 plus square root of x plus 10. This gives me 1 over square root of x plus 10 plus square root of x plus 10, which gives me 1 over 2 square root of x plus 10. This is the expression. This is my first derivative. This is the expression for my slope. So now if we want to plug in the point -1, 3, I'm going to plug in -1 where the x is. So that gives me 1 over 2 times -1 plus 10. That's messy. Let's try that again. So this gives me 1 over 2 times square root of -1 plus 10 equals 1 over 2 times square root of 9 equals 1 over 2 times 3, which gives me 1 over 6. Okay. So now we're going to look at average velocity versus instantaneous velocity. So average velocity, let me get a pen. Okay, is the average velocity between two different points. Basically, think of it like slope. So your average, your velocity average, so let me make my pen thinner, is your change in distance. Oops, let me make it smaller. So it's my change in distance, pencil. My change in distance over my change in time which equals your function of b, which is basically like your y2 minus your y1 over your x2 minus your x1. So think slope. y2 minus y1 over x2 minus x1. You're basically just finding the change. Okay. Instantaneous velocity, on the other hand, is the velocity at one specific point in time. Okay. So I don't want to know what's changed from one point to another. I basically want to know how fast am I going at a specific point in time. And so that, your velocity with time, let me change my pen width, is my limit as h approaches 0 of f of, instead of x, we're doing t for time, plus h minus f of t over h. So basically, your instantaneous velocity is your first derivative. That gives you the expression. So just like on the last screens, this limit process here gave you slope of a line, it also gives you instantaneous velocity at any point. Okay, one thing that you need to change is this is supposed to be t cubed, and somehow I forgot to put that on there. So I want to find the average velocity in miles per hour, okay, where t is time in minutes. So we're going to have to do all this in minutes. This is minutes, but we're going to have to convert it to hours afterwards. So if I want average velocity, you're basically just going to have to find slope. So if I plug in 0.4 times 3 squared minus 1/20 times 3 cubed, that's going to give me 2.25. So that coordinate is 3, 2.25. If I plug in a 5, 1/20 times 5 cubed, that gives me 3.75. That is 5, 3.75. So my average velocity is my the average velocity is 3.75 minus 2.25 over 5 minus 3 gives me 0.75, but that's miles per minute. But I want miles per hour, so I have to convert it. There are 60 minutes in 1 hour. Cross off my minutes, that gives me 45 miles per hour. Okay, example 7. Tourists standing on a 300-foot tall viewing tower often drop coins on the fountain below. The height of the falling tower is given by the equation h of t equals 300 minus 16t squared. So find the equation for the instantaneous velocity of the coin at any point in time. So my velocity is going to be equal to your limit as h approaches 0 of 300 minus 16 t plus h squared minus the function itself. Oops, I probably don't need this. All over h. So that gives me my limit as h approaches 0 of 300 minus 16 times t squared plus 2th plus h squared minus 300 plus 16t squared over h, limit as h approaches 0. So now you need to distribute the minus 16 to each of these. 300 minus 16t squared minus 32th minus 16h squared minus 300 plus 16t squared over h. Okay, so give me a second. I'm going to have to shrink this a little so that I have some more room. Okay. So now I have my limit as h approaches 0. The 16t squared will cancel with the minus 16t squared. The minus 300 goes with the 300. And I'm left with these two, both of which have an h. I'm going to factor out an h. Negative 32t minus 16h over h, which gives me my limit as h approaches 0. My h's will cancel. Oops. So I don't need this anymore. Of negative 32t minus 16h. Now I can substitute my 0 in for my h, and I'm left with negative 32t. So my v of t, my velocity equation, is negative 32t. So then if I want to find the instantaneous velocity after 2 seconds, all I'm going to do is plug in 2. So my velocity after 2 seconds is negative 32 times 2 would be negative 64 feet per second. Okay. The distance a bumblebee flies along its path given by the equation 12 minus 6t cubed, 12t minus 6t cubed plus 1, where g is given in seconds and the distance the bumblebee is from a starting point is given in inches. So I'm going to find the instantaneous velocity. So kind of ignore the double the. So we're finding my limit as h approaches 0. Okay, I'm just going to use my... Okay, I just had to find a better stylus. Okay, so we're going to plug in 12t plus h minus 6t plus h cubed plus 1 minus the function itself. Okay, so there's going to be a lot of simplifying. As h approaches 0, this is 12t plus 12h minus 6. Now, the t plus h cubed, if you remember, your coefficients for that are 1, 3, 3, 1. And then you start out high. T cubed, t squared, t, no t, or t to the 0. And then with the h, you start out low. H to the 0, h to the first, h to the second, h cubed. And since it's plus, there's a plus between all of them. So that's this, if you remember from doing your binomial expansion. Plus 3th squared plus h cubed. Okay. So then it's minus 12t plus 6t cubed minus 1 over h. So my limit as h approaches 0 of 12t plus 12h minus 6t cubed minus 18, 3, t squared h minus 18th squared minus 6h cubed minus 12t plus 6t cubed minus 1 over h. So now I can cancel out my 12t, my 6t cubed, and my minus 1. Oops. I forgot the plus 1 on the end. So there's a plus 1 in here, but it's going to get canceled. So then I'm left with my limit as h approaches 0. All that's left is my 12h, my minus 18t squared h, minus 18th squared, minus 6h cubed over h. Okay, so take a minute and copy that down or pause it because I'm going to shrink this whole thing so that I have more room. Ready? Go. Okay. So now I have my limit as h approaches 0. I'm going to factor out an h, 12 minus 18t squared minus 18th minus 6h squared over h. So my limit as h approaches 0 now, I can plug 0. Oops, I don't need this anymore. Oh, never mind. Hold on. I'll wait. So 12 minus 18t squared minus 18th minus 6h squared. Wait, 18th squared. No, never mind. Sorry, I'm losing my mind. Okay, so now I can plug in 0 into here and into here. So it's going to leave me with my velocity expression is 12 minus 18t squared. Because when I plug in 0, these are gone. And then if I want my instantaneous velocity after 5 seconds, I plug in 5. It gives me negative 438 inches per second.